The Jamaican government is developing plans to reconstruct 120 miles of highway along their beautiful north coast. Stanley Consultants of Muscatine, Iowa has been retained as the design consultant. Marshlands are common along the alignment. The early constructions crossed these very weak soils with corduroy and with sub-excavation and replacement techniques. Stanley Consultants and Ministry Project Manager Carl Martin look to newer technologies. The folks at Stanley Consultants wanted to see if geosynthetics could be used to facilitate building a working platform over the marshlands. Assuming that geosynthetics would be relatively expensive in Jamaica and that fill heights would be more than 2 feet, the test design included a minimum 24-inch lift thickness and 4-ounce woven and non-woven fabrics. The test site was cut and cleared. A river run gravel was tried first. The heavy trucks, loads of 25 to 30,000 pounds per axle, rutted this section. A clean limestone chip was tried next. Again, rutting was severe. The most common and least expensive fill in Jamaica is marl, which is a weak limestone bedrock that is ripped and used as borrow. Marl was tried, and with the expectation that it would surely fail. The marl was outstanding. It set up immediately, and the super heavy trucks had no problem with marl in lifts of 24 inches or more. In fact, lifts of 20 inches would support the heavy loads.
Place the geosynthetic over the vegetation. Limbs and logs add additional support. Overlap geosynthetics by at least 2 feet or sew them together with a J-seam. This is a critical construction element. Pin the edges of the geosynthetic. Wooden stakes work very well. Place fill material first in the center, then work toward the edges. This maintains tension in the geosynthetic.
This project is incorporating MSB fortress abutments to prevent serious foundation problems. There's 90 feet of zero blow count soils at this location. Traditional abutment fills could fail. And a bridge on deep foundations would certainly experience severe bumps at the approaches. Fortress abutment construction begins with geosynthetic support and a nominal 2 feet of marl. Vertical drains are installed to accelerate pore water dissipation. We construct a reinforced base or pedestal as a platform for the fortress abutment. This reinforced foundation is 5 feet thick and faced with ordinary concrete building blocks. The fortress abutment is built on the reinforced platform. We use Martin blocks for facing. Martin blocks were developed for this project by Jamaican project personnel. Upon completion of the abutment, a surcharge is added to accelerate settlement before girder placement. The surcharge is removed and the girders are placed on a spread footer. Fortress abutments and piers are superior to traditional deep foundations in many locations. These reinforced soils are stiff in that they act as a beam during settlement, yet they are flexible and can undergo large deformations without loss of strength. Fortunately, this new and better technology is also much less expensive. At this bridge, Jamaica will save $500,000 in construction cost and avoid a great deal of long-term maintenance.
Place geosynthetics flat and free of wrinkles. This keeps the entire geosynthetic sheet in tension. Place seams normal to wall face. Overlap at least 2 inches. Compact backfill in 6 to 8 inch lifts. Uniform density is important. Place facing blocks with care. Quality workmanship is evident in the end product. Sand bedding may be used to aid in leveling the facing blocks. Again, get these blocks well aligned. Compact in and around the facing blocks by hand. This locks the blocks in place. Good compaction is very important in MSB construction. This is an essential factor in creating this composite.